This is my fourth video on the topic wave. In this topic, I'm going to discuss about the relationship between the phase difference and the path difference of medium particles in wave propagation. So we'll find relation between phase difference and path difference of two particles in wave propagation. In my second video, I derived the equation of the simple harmonic waves as y is equal to a sine omega t minus kx. It represents a progressive wave moving x direction when the oscillator is at the origin at t is equal to 0. So this represents a progressive wave which is traveling to the positive x direction when the oscillator is at the origin and at time t is equal to 0. During the derivation of this equation, the logic we used, same thing I am going to repeat in this video, and then we will derive the relationship between the phase difference and the path difference. If I draw this wave, x-axis, this is y-axis, this is the origin O, and say this is the wave, this is traveling. A particle is at the origin and this end is vibrating simple harmonically, so its amplitude y will be a sine omega t. This we have all discussed in my second video on waves. If we consider any point A, say this is the position A, the particle at A will receive the energy which is traveling from O to positive x direction with speed v. And say this separation from the origin, this point A is located at x distance. So time taken by the wave or the energy to travel from origin to point A, it will take a time t that will equal to distance divided by speed x by v. So in terms of phase, the phase of the particle at A will always lag with respect to the origin. So the phase of particle at A will lag with respect to origin, say by phi. Phase of the particle at A will lag with respect to origin, say by phi, and this phi we can calculate as omega into time. Time is t, so we can write omega times x by v. So if we write omega as 2 pi n and v as n lambda, frequency into wavelength into x. So n will get cancelled out. So we'll get 2 pi by lambda times x. So phi is what? This is the phase difference between the particles at the origin and at A. So this phi is equal to 2 pi by lambda times x. So phase difference we can write. Phase difference is equal to 2 pi by lambda times path difference. So if we know the path difference between the 2 points, we can calculate directly the phase difference between the 2 particles. And 2 pi by lambda, as we have discussed before, is equal to k, which is known as angular wave number. So this concept we will use in the problem involving the wave motion, as well as in case of superposition of waves. So this concept we are going to use first wave motion related problem. Wave motion related problems, and second, superposition of wave. Superposition of waves. So this concept we have used in my second video also. Same thing I repeated here, but just to highlight, the phase difference is equal to 2 pi by lambda times the path difference. Thank you. See you in the next video. In my next video, I will take up some questions from S.C. Burma, which is related on the finding the wave equations, and 1 or 2 problems from the R.C. Sarora book. Thank you.